Example 3, decay function models. The purchase power of $1 is decreasing at a rate of 6.1% annually, compounded continuously. So there's that compound continuously. And what formula do we use? If you said yes, you are absolutely correct. A equals PE raised to the RT. So here we're asked to find out how long would it take for the purchase power of $1 to be worth 45 cents. So round your answer to the nearest hundredths. In other words, leave 2 decimal places up. All right, so let's go ahead and plug everything into So P is what it presently is. So the purchase power of $1. So it's at $1 right now. And with it decreasing or decaying, the future value is going to be less. What is it going to be? Yes, 45 cents. So A equals 45. So remove the P, replace it with a dollar, remove A, and replace with 45 cents. And our rate, because this is decreasing, it signifies a decay. So we need to make sure that when we turn 6.1% into a decimal by moving 2 places to the left, that's going to be 0.061. It needs to be a negative because it is modeling decay or decrease. So we're going to go ahead and plug in everything we know. There you have it. Now we don't know T. That's what we're going to find out, is how long is it going to take. So we have to solve this exponential equation. So step 1, we want to work toward isolating E. So what's my first step in doing so? If you said divide by $1, you're absolutely correct. Let's go ahead and divide by that $1. And you say, well, why am I dividing by that dollar? Well, if we want to get E by itself, right now, E is being multiplied with $1, and so you have to use the opposite operation. The opposite of multiplication is division, and you want to divide by what you want to get rid of. So since we want to get rid of that dollar, we want to divide by $1. And you know what the rules of equation says, whatever you do to one side, you must do to the other. So once we cancel that dollar out, the common term at the top and the bottom, what we're going to be left with on the left side is 0.45, and on the right side, E raised to the negative 0.061t. Our next step to solving for T, we're just kind of peeling away at these layers. Now we want to get rid of the E. And how do we get rid of that? Again, we have to do some opposite operation. So by now you should know you're going to do what? Yes, you got it. Take the natural log of each side. Whatever you do to one side, you do to the other. By doing so, those two, they cancel each other out, and what you're left with on the left side is negative 0.061t. Last step, and we'll be done with this problem. What do we need to do at this point? Yes, we want to get T by itself. Right now, it's being multiplied or sandwiched with negative 0.061, so we want to get rid of that by dividing by negative 0.061. Whatever you do to one side, you do to the other. And once you type in your calculator the natural log of 0.45 divided by negative 0.061 and press enter, what you should get is the value of 13.09, which is choice